So the big number inside, that's called our dividend. What you're dividing by, the 21 is the divisor. Colin, how do you do division, long division? Without calculating.
You would take number, the dividend and divide by the divisor. And, you would just see like, how to explain it. Like I do have to explain it.
Hannah?
I never started.
Okay.
So you would see the number on the outside, how many times it goes into each digit on the inside. So it doesn't go into 8, so it's 0 on the top. But it goes into 82 3 times. And then you multiply 3 by 21 and put it under the number and subtract.
Yeah, very good. So that was a good explanation. Starting with the 21, that's your divisor, and the first number, because our goal is to eliminate the first piece. Well, 21 is bigger than 8, so it doesn't divide into 8, so that's why she said place a 0 on top. Moving to the 82, though, the next digit, 21 goes into 82 3 times, she said, and then you multiply. So, Hannah, 21 times 3 is? 63. And then you're subtracting those two numbers. Hannah, 82 minus 63?
That is. Sorry, I'm really bad at
19?
19.
If this number is bigger than your divisor, that means then that it could have divided into the first value. It's smaller, so we're good to go. What do you do next? Do you remember?
Yeah, you bring down the 3.
Yeah. So bring down the next number and you divide again. So we have 21. How many times does 21 go into 193? Carrie? 9 times. Carrie, 21 times 9 is?
189.
189. And then when you subtract those, Carrie, again? 4. Bring down the next number, dividing again. 21 goes into 45 twice. So I'll place a 2 up there, multiplying, and then subtracting. I would bring down the 4. And I have to do this one more time, pretty much until we run out of numbers. So 21 goes into 34 one time. And when you subtract, you get 13. Does anybody remember how you write the remainder? Phil.
Is it R?
So you could write an R and then have a 13 next to it. How else did you write a remainder?
Is it a decimal?
As a decimal, so you can convert it into a decimal. Any other way? Carrie?
13 over 21.
Yeah, so we would write, my answer is 3,921, and then in addition to that, it's 13 over 21, because that's the fraction that's remaining, that's what's left. Now, usually, you are told to continue to divide until you get it exact, and you find all the decimals. So like if I continued, I would put a decimal here and add a 0. And then I would pull down the 0 and keep dividing until the problem is done. And sometimes they end, sometimes they don't, because they are numbers that just don't ever end. They'll just keep dividing. So we are going to do this today, but with x's. I wanted you to remember the concept of dividing, because whether you're dividing with numbers or x's, it's the same concept. So we started with 21. We asked ourselves, how many times does 21 go into 82? Or what would you need to multiply 21 by to get close to 82? And then we subtracted. We're using that same thought process to do division with polynomials. So the first question underneath wants you to find the zeros. It says to graph this, so go in your calculator and graph this. And then find any real zeros. The power is 3. So thinking about that intermediate value theorem, look at your graph, track the x-intercept or the 0 in between those two numbers, and then write down the 3 zeros that would exist. 2 of them are really close to each other. So that you might have to like zoom in, but two of them are really, really close to each other. There are 3 zeros. Hi, that's okay. That was my math. So it just barely goes over the x-axis, but it really does, twice with that little max, that curve. So if you zoom in, you can see it a little better. So again, when you're getting those zeros left bound, right bound. The first one of them is really easy to find. Carrie, did you get one?
Yeah, 2-0.
2 0. How about another one, Emma? 1/2 0. And then there's one almost right next to that. Did anybody get a third one? Lauren, did you get a third one? 0.6 repeating, yeah, or 2/3 0. So I have a hand-drawn graph. And again, if you zoom in, these two right here, one's crossing at 1/2, the other one's crossing there at 2/3, but they're really close together. So getting the calculator to find those, you have to kind of pick numbers that are really close together so that you can track both of them in the calculator. That's kind of what the graph looks like. So underneath this problem, it shows you how, or reminds you how to set up division. So we have those terms here. Divisor is always what you're dividing by. The dividend is the big part you start with. That's what we're trying to break down. So dividing is a way to break down a number. The answer is always a quotient. So the answer to a division problem is called the quotient. That's what's on top. The little bullet here says if x equals a is a 0, which is what we just found. These are zeros. We can take a 0 and write it as a factor by just taking this and writing it as x minus 2. Now I have a factor. Or I could take this one and write it as x minus 1/2. Or I could take that one and write it as x minus 2/3. So a 0, remember, is a factor. I can think of them either way. The reason we're going to think about it as a factor is because then it gives us something to try and divide. So it says in this little area down here, this is how we will be writing our answers. So our function, the goal is to take a function and break it down. We're going to break it down using the divisor times the quotient. So what I was dividing with, the thing outside, times my answer. Because if I multiply those back together, I can go back to the original problem. Whatever's left over, the remainder, gets added to that afterwards. So divisor times quotient, what we were dividing with, times the answer. If there's a remainder, that's the addition part that I added to it, because I should be able to FOIL and get back to the polynomial. Just like when we're dividing, we should be able to multiply to get back to our original problem. So FOILing is multiplying, except now we're looking at x's instead of just multiplying numbers together. But I should be able to multiply these two together, add 13, and get back to 82,354. So the first problem that we are going to look at is this same function that we just started with. That's the function at the top. And we are going to try and divide by x minus 2, which is one of the factors that we found, or it was a 0. Same thing. So we are going to set this up. Whatever follows the word by is your divisor. So that goes outside. That's what we're dividing with, this x minus 2. So make yourself a little division bar. You got a lot of space because we're going to use all of that space. The dividend is the big function. So what function are we trying to break down? Remember, dividing is a way to break down. That goes underneath our division bar. So 6x cubed, negative 19x squared, 16x minus 4. So when you're dividing by outside, what you're trying to break down inside. The bigger part should be inside. Now with dividing variables, it's pretty much the same, but we have to kind of tweak the process a little bit. The 2, the negative 2, is not really part of our thought process right now because our goal is to eliminate one term at a time. So when you look at the x minus 2, think that the 2 isn't there. We're going to just look at the x, and we're going to look at the first term because we're just one term at a time, which is the 6x cubed. And you need to ask yourself, what would you multiply x by to make it 6x cubed? Just like we did with the first problem. We needed to figure out what we needed to multiply 21 by to get it close to 82. So if I have an x, what would I multiply it by so that it becomes 6x cubed, Dylan? You're close, I agree with the x squared. Oh, I need to move my hand. Yeah, so 6x squared. So I have an x. To make it 6x cubed, I would multiply it by 6x squared. On the side, I'm going to do a little scratch work, which you might have to do the first couple of times, because the next step is now to actually multiply. So whatever I put on the top, notice I placed it above its like term. He said x squared, so I placed it above the x squared term. We're going to take 6x squared and multiply it by the divisor, because that's how I get the stuff underneath. I take the value on the top and multiply it by the value on the side. Well, we happen to have an x minus 2. So Dylan, if you multiply that, 6x squared times x is 6x cubed, which was our goal, to eliminate the first piece. And then Dylan, 6x squared times negative 2 becomes, say it again. Yeah. Your like terms should be lining up vertically. Your powers need to be the same. What do you do with these two pieces then? So think of the division problem above. What did we do next? What symbol goes outside here? Hannah? A subtraction. So now we're going to subtract. So we found the product. We're now subtracting these two pieces. Here's where the most mistakes are going to be made. When you're subtracting all of this. So that means I'm subtracting the 6x, but I'm also subtracting the negative 12. And when I have a minus negative 12, really I'm now adding that. So that minus sign, I have to subtract everything after it. So I have 6x cubed minus 6x cubed. The goal was to make this cancel, and now it does. I then added negative 19x. Now it's adding 12 because a minus negative turns into addition. So Josh, negative 19 plus 12 is? Right, negative 7x squared. So what do you think you do next, Josh? Yeah, we're going to bring down the 16x. There we go. So bring down that 16x, and then I start the process over again. Because I just need to keep going until I'm out of x's or out of numbers. So covering up the negative 2, just looking at the x, you need to ask yourself, what would you multiply x by so that it becomes negative 7x squared? Garrett, what would you multiply x by so that it becomes negative 7x squared?
Negative 7.
Yeah, negative 7x. And again, that goes right above the x term. And then you're taking that negative 7x and actually multiplying it. But now you're multiplying it by the whole divisor. So Garrett, if you take negative 7x times x minus 2, you get?
Negative 7x squared plus 14x.
big subtraction sign. And then actually do your subtraction. Just be careful with the signs. So a minus negative turns into a plus, a minus positive turns into a minus. So Garrett, if you subtract them, what do you have left?
2x.
Perfect. Bring down the minus 4. And we're pretty much done because I ran out of numbers up there in my polynomial, so I have to just divide one more time. So ignore the negative 2. You've got an x. Colin, what would I need to multiply it by so that it becomes 2x? So we have x. What do we need to multiply it by to make it 2x? 2. And then 2 times x minus 2 makes what, Colin?
2x minus 4.
Again, in a big subtraction sign, so I'm subtracting the 2x but adding the 4. What's your remainder? 0.
Yay.
Does anybody know why we got a remainder of 0? Josh, what do you think?
Because it fits into it perfectly.
It fits into it perfectly because that x minus 2 was a 0 in the graph. We said initially x was equal to 2. It was an x-intercept. It was a 0. So my remainder is 0 because it is a 0. Correlates together. It means something when you get a remainder of 0. It divided evenly in the problem. Questions? Is there anything else on that page? No, okay, I didn't think so. So if you flip, there's like, what, 4 problems on this page, I think? 1, 2, 3, 4. We're going to just go through and see if you feel a little more comfortable as we work through more problems. So we have, is x plus 1 a factor of 6x cubed minus 19x squared plus 16x minus 4? So our goal is to see, is this a factor? And the way we can do that is by dividing. So we can kind of divide and see what our answer is, and that'll help us decide if it's a factor or not. What goes underneath the division sign? The big polynomial. So the little big polynomial goes underneath, the little part, x plus 1, that's our divisor. So we're going to try and divide with that to show that it's a factor, to show it's not a factor. So the little piece always goes outside, because our goal is to break down the big function. Oh, I guess we didn't write our answer correctly on the last one. I'll make sure to show you how to write the answer. We should have formalized our answer. So cover up the plus 1, only look at the x. Lauren, if I have an x, what do I need to multiply it by to make it 6x cubed?
6x squared.
Right, and anytime you say that power, it should line up vertically with its like term in the divisor, or I'm sorry, the dividend. And then Lauren, if you're multiplying 6x squared with x plus 1, what goes underneath?
6x cubed equals 6x squared.
If you need to write that little scratch work so that you can physically see what you're multiplying, that's okay. Until you get the hang of it, it's alright to write it on the side. And then subtract. So be really careful with the minus signs here. What do you have left over, Lauren, when you combine them together? Right, negative 25x squared. So just be careful that minus sign carries through everything. I'm subtracting 6x cubed, I'm also subtracting 6x squared. Bring down the next number, or term. And now we do it again. So Reese, we have an x, we want to multiply it to make it 25x squared. So what do we multiply by? Negative 25x. And when you do that, what do you get?
Negative 25x squared minus 25x.
big subtraction sign, which really means we're adding this, and then what do you have, Reese, when you add those together?
41x minus 1.
Nice. So now we have 41x minus 4. So carry the last part here. I have an x, I need to make it multiply it by something to make it 41x, so
41.
that would be a 41. And when you multiply 41 times x plus 1, you get
41x plus
41x
41 plus 41.
plus 41, yeah. Subtract, and what is your remainder?
Negative 45.
Negative 45. So I do want to show you how to write this, and then we'll answer that question as well. So we're going to start with f of x. That's the original function. So your original function is equal to. Our divisor is what we were dividing by. That's the x plus 1. And then the quotient. What do you have on top of your division bar? That goes next. So on top of the division bar, we have 6x squared minus 25x, and then plus 4. That goes in parentheses. How about 41, not 4? The remainder goes after. So this is saying that my original function is now broken down. I can still find it by re-multiplying through the problem to go back to the original. So our answer here, the divisor, the quotient, and then the remainder. That's how you will write every single answer. Divisor times quotient, and then plus the remainder if there happens to be one. That's to show that our problem, our original equation, was broken down. So the question is x plus 1 a factor? So is what we divided with a factor? Why not, Josh?
Because there is a remainder.
Right. So it is not a factor because of that remainder. So no remainder, it is a factor. If there is a remainder, it's not a factor. It's not a zero. It's not an answer. It's not an x-intercept. However you want to use those words, they all mean the same thing. So not a factor because there is a remainder. It didn't divide evenly. Questions? This is one of my favorite things to do. We'll do it again throughout the year, like just kind of sprinkle it in. I just think this is wonderful. I was so excited to teach this on a Friday, even though it's Friday. I was really excited this morning. I'm a nerd. It's okay. All right, so example 3 is set up a little different. We have a big power of x to the 5th on the top, plus 7. On the bottom, we have x cubed minus 1. Remember, the bigger power always goes underneath. And if you look at mine, I have it set up so that you can kind of see where pieces of the problem are going to fall. And even though this is an x to the 5th plus 7, we're going to expand this problem so that the powers are represented in the problem, so that like terms line up nicely. So the x to the 5th is going to go right here. And then instead of putting a 7, I'm going to put a placeholder. And that placeholder is going to represent x to the 4th. There isn't an x to the 4th, but our powers need to line up. So I'm just going to place a 0 in. So to represent x to the 4th, I'm putting a 0 there. And then x cubed. And then x squared. And then x, because a polynomial is a list of powers that descend in order. And then finally, the number that we do have is a 7. So the reason we expand is because when we're subtracting or looking at our like terms, then our like terms are kind of following in place. Everything is lining up nicely. The x minus 3 is our divisor. Whatever you're dividing by when it's in a fraction form is always in the denominator, because you're taking x to the 5th plus 7 divided by x cubed minus 1. So now we only look at the x cubed, only look at the x to the 5th, Colin, what would you multiply x cubed by to make it x to the fifth? X squared, yeah. So I'm going to go over to where my x squared is. Place the x squared. And then I'll multiply. So we're taking x squared times x cubed minus 1. Colin, what is x squared times x cubed?
X to the fifth
X to the fifth
minus x cubed.
minus 1x squared. So distributing this guy through my problem. So now I have those powers that are lining up with each other. We subtract, which means this turns into a plus sign. And then you add everything vertically. Well, x to the fifth minus x to the fifth is gone. I don't have an x to the fourth, I don't have an x cubed, but we have a 1x squared. And then bring down the 7. So going back to the process, you have an x cubed. Is there anything you can multiply by to make it x squared? I mean, technically, I guess a negative 1, but no. Once the power here is smaller than what you started with, you're done dividing. And that's how division works with numbers. So once we end up with a remainder that's smaller than what we started with, smaller than our divisor, then we are finished dividing. So this one we actually only divided once, because that was as far as we could go. So when we write our answer, f of x equals, my quotient is x squared. Because it's just x squared, I'm going to write it first. Our divisor is x minus 1. And then the remainder is x squared plus 7. So if I multiply x squared through x minus, or sorry, this is x cubed minus 1. I missed my little cube there. So if I multiply through, combine the like terms, we should be able to get back to the original problem. Questions? See if you can try example 4. So we have x cubed, 0x squared, a 0x, and then the minus 1. So try and think of expanding that piece. So the dividend, that big part, we want to expand it so our powers are lining up vertically. Does anybody remember when you learned long division? 4th grade? Maybe 3rd grade? Somewhere in between?
Third grade, yeah.
3rd grade?
Third
I don't know, I'm trying to think. I knew you learned to divide in 3rd grade. It might be 4th grade. I'll
I
have to
think
see
we
what
learned
Sadie
how to
does.
divide, but then long division.
Long division might be, yeah, I think long division might be 4th grade.
Multiplication. Because of the, like, minute ends or whatever.
Yeah.
I think we did
Or
the,
man
I think we
Math
did,
minute test?
yeah, I think we did.
It was so bad at those, I couldn't get past 2.
Oh, yeah,
Of course, they now have an app for that.
Yeah.
Yeah, and it's a fun game. Like they play games. It's just a whole big gaming process so that you have your
They should just
numbers
throw it back.
memorized. Yeah.
Yeah, they should screw up, that's
It's actually a pretty good app because my older daughter got it in 3rd grade, and I was so like skeptical. I'm like, this is not going to work. She's never going to remember math facts from using an app. It works. Sometimes apps work. Carrie, we got an x. We want to make it x cubed, so we multiply it by
X squared,
x squared. And when you do that, underneath you get
x cubed minus x squared.
big subtraction sign. Adding vertically, our x cubes cancel, and we still have an x squared. So I can keep working through. Josh, we have x, we want to make it x squared, so
Let's take out
well, we pull down a 0. So So Josh, if we have an x and we want to multiply it by something up. So just an x. And multiplying x times x, x times negative 1, and then subtracting. That again is a plus sign. So now I have a 1x, and I bring down the minus 1. Brenton, what do you multiply x by to make it x? Just a 1. What's the remainder, Brenton? So when we subtract, we get a remainder of 0. What does that mean about what we divided with? Yeah, this is a factor. So when you write your answer, we divided with x minus 1. Dividing is breaking it down. And then I have at the top x squared plus x plus 1. And then there is no remainder, so I don't have to put a remainder back here because there is none. What do you think? So there's one final problem, and that problem is different than all the others because the divisor, I believe, is that x squared plus 2x minus 3. So the divisor is a little bigger. I'm going to see if I can get this to work again. See if you can start dividing. Example 5. I think it's so you don't need to do any factoring or anything like that. Yeah, thank you. Yes. So only looking at the x squared. You only use the first term. Ignore the minus 2x and the minus 3. You're trying to look at 2x to the 4th. What do you need to multiply x squared by to make it 2x to the 4th? Dylan? 2x squared. So he said 2x squared. So I'm placing that above my x squared term. And then you're actually multiplying. So Dylan, 2x squared times x squared is? 2x squared times 2x is? 2x squared times 2x.
4x.
And then 2x squared times negative 3.
Minus 6x squared.
Good. And then you subtract. So now you're subtracting 3 terms. Be careful with that minus sign. So minus, plus. Carrie, what happens when you subtract?
Everything cancels out except x squared.
Yeah, so your 2 terms cancel in the front. X to the 4th cancels, x to the 3rd cancels. What are you left with? You said just an
X
x.
squared.
How many terms do you think you bring down if 2 cancel? 2. So I have to bring down the 3x. We have to bring down the minus 2. 2 terms cancel, 2 terms get brought down. Because I have 3 that I'm dividing with, and I still need to have 3 down here in my answer. Lauren, we have an x squared. What do we need to multiply it by to make it x squared? Well, just a 1. So x squared plus 2x minus 3. Be careful you're subtracting. Just be really careful that you're pulling that subtraction sign through. And you should end up with x plus 1 as your remainder. So writing this here, we have x squared plus 2x minus 3, 2x squared plus 1, yep. And then my remainder is x plus 1. Questions? Probably in 4th grade you never thought you'd divide with x. Maybe not even last year or this year you thought you'd divide with x. So you have 10 problems for homework tonight. The first 3 problems are more like trying to answer a question. It's not really division. When you get to 9, that's when 9 to 21, you'll start the long division process. So there's 7 long division problems. Any interest, somebody to do 13 and 17? Reese, you'll do 13. Carrie, 17? Have a fantastic weekend.
Except for that English quiz.